So you can think of factoring as reducing fractions. For a fraction to be reduced, it is as low as it can possibly go. And with factoring, it is very important that you understand multiplication. There's a lot of visual effects that go into factoring, being able to see a number and knowing what goes into it. So if I want to reduce this fraction, 36 over 60, and let's say that I can't immediately see the numbers that go into them, well, it's like we were doing before. Break down 36. 36 breaks down into 6 times 6. And we can continue to break it down further. 6 breaks down into 2 times 3. And so since I have it listed as prime factors, I've got everything covered. So what about 60? 60 breaks down into 6 times 10. And 6 breaks down into 2 times 3. 10 breaks down into 2 times 5. And so when you reduce it, the 2's cancel out because 2 divided by 2 is 1. The 3's cancel out because 3 divided by 3 is 1. The 2's here cancel out because 2 divided by 2 is 1. And so I'm left with a 3 over 5. So 36 over 60 reduces down to 3 over 5. That is as low as it can go. Well, a lot of ways I could have saved myself some steps when I broke down 36 into 6 and 6 and 6 and 10 and 60 as 6 and 10. I could have started here and saw, oh, hey, my 6's break down and I'm left with 6 over 10. But as we just learned, 6 over 10, well, we can reduce that down even further, and so that reduces down to 3 over 5. So what we're going to be learning in this unit when it comes to factoring is how do I know when I'm finished? Our goal of factoring is to break it down into the lowest factors possible. And so again, to start with, to ensure that we're doing that, we always want to start with that GCF. So I have 3 examples that we're going to look at, and our goal is just to find the GCF, to factor starting with GCFs. So let's take a look at the first one here. So I have 60x to the 5th minus 24x to the 4th plus 36x to the 3rd. So I've got to look, I'm going to start with my numbers. I've got a 60, a 24, and a 36. So what goes into all 3 of those numbers evenly? Well, I'm looking and I think, oh, hey, maybe it's a 6. So I'm going to factor out a 6. So then, let's say that I don't see the x's to start with. So when I factor out the 6, I'm left with 6 times 60 is 10. Or sorry, 6 times what is 60? 6 times 10 is 60. Then the x to the 5th. 6 times what is 24? That's 4. And then the x to the 4th. 6 times what is 36? That is my 36. And then the x to the 3rd. So how do I know that I have the GCF? Well, look at what I have remaining in the parentheses. Is there something else that I could have factored out to start with? Or do all 3 of these terms have anything else in common? And the answer is yeah, we do. So 10, 4, and 36, they actually all also have a 2 in common. So I don't want to forget about my original 6 that I factored out. But now I'm going to factor out a 2. And let's just go ahead and just state the fact that we also have x's in common. So what's the greatest amount of x's that I can factor out? Well, this one has 3 x's, this one has 4, and this one has 5. So the greatest amount of x's that we have in common is an x to the 3rd. So now I'm going to cover up the 6 because I don't want it to get in my way. And so now I'm factoring out this polynomial here. So my GCF is 2x to the 3rd. So 2x to the 3rd times what is 10x to the 5th? Well, 2 times 5 is 10. X to the 3rd times x squared gets me x to the 5th. 2x to the third times what is negative 4x to the fifth? 2 times 2 is negative 4. Well, 2 times negative 2. X to the third times x is x to the fourth. Then 2x to the third times what is 36x to the third? Well, 2 times 18 is going to get me 36. And I've already factored out the x's, so it's just an 18. So now, take a look. If I had actually factored out, to start with, a 6 times 2, a 12x to the third, I could have done this in one step. So 12x to the third is my GCF, that's my height, and my length is 5x squared minus 2x plus 18. Now, our lesson today is on GCFs. The truth is there's a chance I can factor this down further, taking this trinomial and breaking it down into linear factors. But before we even begin with that lesson, we have to understand GCFs. So let's take a look at example 6. In example 6, if I want to try to get this in one fell swoop, what do both of these terms have in common? Well, there's not any numbers in front of each of them, so the only thing they have in the common is the x's and the y's. So if I factor out the x, because they have an x in common, and it looks like they also have one y in common, it appears that I have a GCF of an xy. So then xy times what is xy squared? How about y? Because x times 1 is x, y times y is y squared. So xy times y is xy squared. xy times what is xy? Or xy times what is negative xy? Negative 1. So my GCF was xy, or I have a height of xy, and I have a length of y minus 1. When I look at what I have inside the parentheses, that is as low as it can go. There is no more GCFs. So now for my last example. So let's start and let's try to get our largest number. So we have a 32, an 8, and a 4. So I'm going to start with my 4. My 4 is my smallest, and so my factors of 4 are 1 and 4 and 2 and 2. Since 4 is the biggest number that goes into 4, let's see if 4 will go into 8 and 32. 4 goes into 8 2 times, and then 4 goes into 32 8 times. So we have a 4 that we can factor out. So then now notice how we have x's in common. What's the greatest amount of x's that we have in common? X cubed, x squared, and x squared. So it appears to be an x squared because they all have at least 2 x's. And then we also have y's in common. So it appears that our greatest amount of y's is the single y. So we have a GCF of 4x squared y. So then 4x squared y times what's going to get me 32x cubed y squared? So 32 divided by 4 is 8. So 4 times 8 is 32. X squared times x is x cubed. Y times y is y squared. So then 4x squared y times what is 8x squared y squared? Well, 4 times 2 is 8. X squared times 1 is x squared. Y times y is y squared. 4x squared y times what is going to get me 4x squared y? 1. So now we have successfully factored it out. We started with the GCF of 4x squared y. I'll look at what I have remaining in parentheses, and that is as low as it can go. So before we move on with factoring, you have to first learn how to find the GCF. So in the practice that you're going to have following this is just going to be factoring and starting with GCFs.